Today's video, we're going to be putting electric trailer brakes on a medium duty truck with air brakes. So if you're a guy who's interested in seeing the what, the why, the how, and what we use to do it, stick around. I'm JC Smith. I'm going to show you as I do it. So now we're going to start putting electric trailer brakes on our medium or heavy duty truck that has air brakes. So we need a few things. So we got to pick a brake controller. Now, the brake controller that you want to choose is going to be based on your intentions with the truck. Like this particular model, which is made by Draw-Tite, which Draw-Tite, Hidden Hitch, and Reese, they're all the same company, called Sequent Towing. Don't get caught up on the brand name. They're all the same. This one happens to be good for 1 to 4 brake axles. I can tell you without a doubt, I will never pull a trailer with 4 brake axles ever. So this is more than I need, but at the same time, I have a few of these. So I think I have like 6, 8, 9, 10 of them. I don't know. So it's important to understand your brake controller when you're choosing it, as far as your intentions, what you're going to use it for, and its abilities. There's several types out there. One I prefer, which is made by the same company, but it's called a Prodigy. I really like that one. It works very well, and I've had good luck with it. So some brake controllers are what are called timed, and some are called inertia. So you have to find out which one it is and which one you like better. So what you have is, in a brake controller, it'll take you from 0 brakes. What it's doing is taking an input from an electrical input from typically a brake light switch, which on one of these air brake trucks, we don't have inside the cab like you would on your typical truck. So we have to create a place to get that from, or get it from a different location. Not a big deal. We'll get there. So it takes an input from a brake switch. When you apply the brakes, it pulls that signal in, and this is a big relay, a control relay basically, and it takes power that you're bringing from your battery into here and sending it out to your trailer. Now, if it just hit the brakes and it gave you 100% 12 volts right up at the get-go, every time you hit the brakes would lock up and it would destroy your tires and your brakes wouldn't last very long. So what these do is they bring them up gradually. So you have a time setup where the longer as you push it on there, you're holding their brakes, it takes the time to come up to your maximum voltage. So these will go from 0 to 10. That's the rating, not your voltage. That's your basic settings of your brakes. So we all know that most trucks going down the road running somewhere around 13.4, 13.6 in your voltage. And when you're doing this, you can't go 0 to 13.6, right? So you have your settings that way. So there's one setting that sets your max voltage, or your max setting on your 0 to 10. That'll limit how much power, braking power, you can actually deliver to the trailer. The other setting we have on here is a setting for how quickly it comes up to that point. So if you're pulling real heavy and you've got say a gooseneck trailer with dual tandem and you've got 20,000 pounds on it, you probably want those brakes to come up a little quicker to the max than if you're pulling say a 3,500 pound or 7,000 pound trailer, 3,500 pound axles with a little car on it. You probably want them to come up much slower so that they don't lock up. So that's what that second adjustment does. It basically tells you how quickly it's going to come up. Now, an inertia-based one, the harder you apply the brakes, the quicker it's going to come up, because it's not necessarily on a time. It can be adjusted through the time on the side, but that inertia also comes into play. That's the ones I like, because the harder you hit the brakes, the quicker it comes up to your level. So I need to interrupt the video here because I realize I've only spoke about the 2 trailer brake controllers, the timed and the inertia style, both having an electric input. They both use an electric input, and then the brake controller converts that signal into a way to apply brakes to your trailer. So whether it's a timed setup on how quickly it comes up to that maximum that you've set it at, or if it's inertia, and think of it like a plumb bob hanging. The harder you hit the brakes, the farther this thing goes forward and as fast, and you hit them lightly, it doesn't move as much, right? Both of those use a 12-volt electric input. Now, there is another style that uses air pressure. Now, that one you would tee into your foot valve and tee into your actual output pressure that goes to your brakes. So then the harder you push on your foot valve, the more the pressure, the higher the pressure is that you're sending out. That same pressure is coming into your brake controller, and that's called proportionate, because as much as coming in, the brake controller can interpret that and apply the same proportionate amount of electric to make your brakes on your trailer work. I don't use them for several reasons. One is the fact that they're not plentiful. You don't see them very often. Usually it's special order. Not a lot of places keep them. And to me, that translates into, if I'm out somewhere and I have a problem and it's not working, that means either I'm sitting and I'm waiting for somebody to get one, or I'm going home without brakes. One or the other. I prefer neither one of those. The cost is high. A decent one typically is going to run mid to high threes, maybe into the $400 range. That's not attractive to me for as little as we'll use it, that's for sure. And another reason is you can go into any parts store in your town. I guarantee you your auto parts stores, they all have some version of some type of brake controller that you can buy and use and get you home. Another reason is I have quite a few brake controllers here that are electric input, and I'm just going to use what we have. The air input, guys will argue it's great for a commercial application, but I got to tell you, if I was in that situation and I was in a commercial situation and I needed that on a daily, I don't want electric brakes on my trailer. I want air. So if you want to argue safety, then you probably need to argue the bigger point is why are you using electric brakes on an air brake truck when you have the ability to have an air brake truck? I would probably just run the air brake trailer. That would make me feel better. But I want this trailer to be able to haul anything that I need to hook to it, because it's going to be so little here and there. That's why I choose these. But I just wanted to cover that because there is another option, and I didn't want to let anybody think there wasn't. Make sure we covered it. So we've gone over this. We have to mount that. There'll be wiring to do from that. You'll look at your instructions. It'll tell you what amperage this requires and what gauge of wire they want you to run. In this situation, they want us to run a 10 wire, being good for 30 amps, and use overcurrent protection of 30 amps. So when we're talking about the overcurrent protection and the wiring running to it, we're going to bring all of our power and ground from our battery terminal. We want to make sure it's from the battery. That way we got a good connection that we don't have to share with anything else. If you pull this off of something else, another junction, then what you're doing is taxing that circuit already with the extra load of this, and you could melt or cause damage or stuff like that. So it's easiest to go right to the battery and run your power and your ground both right from your battery source. Now, when you do that, we want to put our overcurrent protection. That's what this is. This is a self-resetting circuit breaker. So basically inside here is a piece of metal, and as a load comes across from one contact to the other, if it gets too much of a load, a predetermined thickness and setting on the actual metal itself, it will heat up. As it heats up, if that load becomes too much beyond its capabilities, that piece of metal inside there is going to pop up like this and open that circuit. So it allows that circuit to become open and eliminates whatever the damage is, the problem, why it is pulling more amperage than it's designed for. When that metal cools down, it's going to close back up. It's going to make contact again. You'll have circuit. If you still have an overcurrent situation, it's going to probably pop right back up. The purpose for using this versus a fuse is because if it is a temporary overload, it will reset and you'll have brakes again. If it was a fuse, when it blows, that's it. It's blown. It stays open. It's not going to have brakes again until you replace the fuse. So that's one of the reasons we do that. This is going to be set up as a 30 amp system. Now, I'm going to tell you, every piece of this puzzle, you're only as good as your weakest link. If you have a 30 amp breaker, and then you get one of these, which is a 15 amp. Yeah, this is a 15 amp circuit breaker. So if you have a 30 amp brake controller, but you've used a 15 amp circuit breaker, well, now your system is only ever going to get to 15 amps. You're never going to get to 30 amps. So you've got to have everything sized accordingly. They want you to run a 10 gauge wire. So I like to run a jacketed wire with a red and a black inside here, in its own protected jacket from the battery into the cab where I need it. I buy this by the roll, and then I can do whatever we want. At your terminations, I like to use a ring terminal. I like to crimp and solder, put deox, and then put my own heat shrink over it. But for ease of this video, most people aren't going to want to do that. You can buy heat shrink connectors made just like this. Yellow would be good for our 10 wire. We'll have some splices that come out of this brake controller that will be 14 and 12 gauge, okay? We need a good set of strippers, nice and sharp, that will go up to 10. And then if you're going to use these, you need to use the proper crimp tool. This tool is made by Klein, and you see the color indications on here. And you'll notice there's no teeth in there. This will make a flat crimp instead of using a crimper that has a spike that pierces the insulation, rendering your heat shrink connector now not weatherproof or something similar to that. Even though my preference is to crimp, solder, and heat shrink with deox, I'm just going to use these so you guys can see exactly how it can be done. And then, of course, you need some way to heat. I use a Milwaukee heat gun. I think it does a really nice job. I don't have to worry about butane anymore. Razor knife, screwdrivers, miscellaneous, and if you're going to use any tape, make sure you use a good quality tape. You can see what this is. This is a 33 plus tape. This is a very good 3M product. You get that Home Depot, Lowe's, wherever. Good stuff. So now we have all the pieces of the puzzle, and we have our 7-pin already in the truck. We just need to get the wiring. So I'm going to show you a diagram of what we're after, and then we'll go through the actual procedure. Now, there is one more step of this. We have to create a location to get our brake signal. So we'll get to that when the time comes on the air brake, which is probably the biggest thing that people are looking for. So here's a diagram of what we're going to do. Okay, we have a battery, we have our circuit breaker, we have our brake controller, we have our 7-pin at the back of the truck, and then we have our pressure switch. So basically all we're going to do is come off the battery. We're going to take a negative straight to here to the 7-pin. So we have that already there. We know it's a good ground that's going to work well. And then we're going to take another ground and come over here into our brake controller to the white wire. That's what that is. The white will be the ground. You see the location here. This is if you're looking at the back of your truck and you lift that little door up and you're holding it up, and that's what you see right there, 7 pins. Then we're going to take a positive line off the battery. We're going to come real close to the battery and hit our circuit breaker. Now our circuit breaker will have 2 terminals on it, and it's very important that you pay attention to what they are. One is battery side, the other one is the auxiliary. The auxiliary is going to be the load. The battery is the supply closest to the battery. It's important that this distance is as short as possible, feasible, because before this, from here to here, there's no overcurrent protection. So if this shorts out, gets cut, gets pinched, rubbed, whatever, there's nothing to stop this from burning up. So we want that as close to the battery as possible where we're coming off of. That's going to then come off of here. That black is going to supply our brake controller. Okay. After that, we need a way to activate the brake controller. So we're going to come off of here again. This is a fuse holder, which again is close to the battery as possible. We want that to be a weatherproof, weather-tight, as much as it can be, fuse. Now, a lot of times guys will take this off the fuse box, somewhere else where it's a little more convenient. Do whatever you like there. But in our case, we can take it right off of our battery source and run a fuse. Then we need a pressure switch. This is nothing more than a contact that has a diaphragm behind it, that when there's pressure on it, that diaphragm pushes on that contact and makes contact between the two. When pressure is removed, it moves away from it and opens the circuit. This is a very simple thing. I get these off of trucks we take apart all the time because there's plenty of them, and they all have to have a brake light switch somewhere. I don't tie into existing. I like to just add my own, so I'm not taxing the brake system already, and if I have a problem, I know right where to go. So it comes out of here, and then that is our red, which I didn't mark. This is our red that comes into the brake controller. So all of this is pretty simple. Now the biggest thing about this at this point is find a place to tie in that pressure switch. So let me get everything mounted up and I'll show you exactly what I did here. So this is my two 10 gauge wires in this loom, and I was gonna run it up and over the engine compartment, and then I looked inside and found that I have a grommet that comes in on the passenger side, which is really close to the batteries, right there. And I think I'm just going to pop that grommet out and cut it so that we can put our loom through it. And I'll run my cable under the dash over to the other side for two reasons. One, because it is a shorter run, which anything in electric and ampacity and voltage drop tells us that the shorter we can make the run, the better. And the fact that it won't interfere with any service work that needs to be done out here under the hood. And it won't have any zip ties or anything up here that have to be cut or potentially get damaged while it's getting worked on. So I'm going to pull that grommet, make the hole big enough, and get our cable across there. So if you take a razor knife and you just cut an X in this, right, you end up with 4 flaps that go around and it doesn't really fit all that well. So I choose to use a ferrule from a compression fitting, tuck it down in there, and then I'll put my piece of wood on top and smack it with a hammer. Perfect hole every time. I'll get it as long as I need first, then I'll slide the grommet on. I always choose a ferrule that's just a little bit smaller than what we're trying to put through. She'll love that I'm in here. She's trying to detail at the same time I'm messing with this. Let's see how much more we need. I think we're still a little short. You know, most people wouldn't want to run it clear across the truck, but it's kind of the same thing. You're either going to run it on the inside of the truck or the outside. And if I have my preference, I want to limit the exposure to the outside as much as absolutely possible. Let's see how much we got. Oh yeah, that's more than adequate. Okay, so now we'll put the grommet over top of this. Have to get some dish soap, make it a little bit easier. Okay, there she is. And they're nice and tight like it should be. No gap around it. I should turn the loom down though so the water can drain out. Yep, okay, let's get it worked over there and put up where I want it. I don't want it to be hanging down. There are some places to tie it under there, so shouldn't be a big deal. Maybe we'll tie this up too. This is supposed to be up here like that. I got my cable worked over here and zip tied, so here's the end of it you can see. And I like to take care of wiring problems as I see them and get rid of them. This was an old liftgate control, so you used to have to turn this on before you got out of the truck so that you could actually use a liftgate. Well, we don't need that. I don't want it, and I got something else that needs to go here, so we'll take that out. And I'm going to try and take care of this. You can see there's not a lot here to work with, but there's so much strain on that. It's pulling on that connector, so I'm going to cut that out, and I'll add a piece of wire in and heat shrink it and solder it, of course. Well, I went ahead and just used a crimp connector in here with, you know, a soldered or a heat shrink crimp connector. So I took the one that was there and I sliced it and was able to get it off and had enough wire left the way it was. I could put it right back like it was. So I think we'll just go with that, because I figured if I'd done it the other way, I'd have 2 solder joints versus 1 crimp joint, and it's inside. It'd be just fine. So this would be my line going to my battery. I'm leaving it this long because I'm not ready to terminate this end. As you can see, I don't have a battery box over here. I'm still looking for fuel tanks. Once I know what fuel tanks I have for this build, I'll know where my battery box is going to go. So I'm just going to leave this long. This is repurposed wire I pulled off another truck, of course. I do this a lot. If I had to buy this wire, man, there's probably, I'm going to tell you, this cost me probably 40 to 60 bucks. And I just pulled it off another truck. So I will terminate this when we know. We'll put a 30 amp circuit breaker on the positive, as close to the battery terminal as we can get. And I'll get one that is weather tight, and I'll show you what one of those types that I have, what they look like. I'll insert a picture here. And then this, I have run over to the other side, and we're ready to, I've got it terminated. I'll show you what we did. We have the trailer brake controller mounted, and it's important to mount it in a place where it's easy to see, easy to get to, because you'll need to adjust the limit of how high it can go as well as how fast it comes up. So it's got to make sure that these are not restricted in wherever you put them, and you need to be able to see the display. Now there's also a slide on this, a hand slide, so you can apply the trailer brakes without touching the brake pedal by squeezing this. The farther you squeeze this, the more it's going to apply. It's proportionate, and the faster you do it, the faster it applies. So that's in place. That's where I want it, and I've got the harness run up underneath the dash over to where I've mounted my circuit breakers. These are secondary circuit breakers, and there's a reason for this. There's a reason for these two circuit breakers in addition to the ones over there. It's because we're splitting off power. Our battery cable comes in here, and this is our positive, this is our ground. Our ground comes into this bolt. This bolt, I've drilled a hole and cleaned the paint up, put serrated washers on either side to ensure it's a good connection. I bolted it to the body first, and then I put my ring terminals on here with a washer and an eye lock to make sure it stays tight. That is sharing a ground. One goes to the brake controller. That's this cable right here. This goes to the brake controller. So that grounds the brake controller. This other one goes out to this cable to the rear for our electric trailer brakes, so we have a good ground for our trailer brakes. Our positive comes into this circuit breaker. This first circuit breaker is for the brake controller only. So our power comes in on the battery side. In a normal position, this is normally closed, meaning there is contact between this post and this post. It comes out of here on this black wire, and that feeds our brake controller. Our brake controller, when you hit the brakes, we need an input. This red wire right here, which goes to the brake controller, is coming from this other cable. You see these extra wires here. I have other things we're going to be adding later, so I ran extra wires. But those are in one of these cables. This one goes to the rear. This one over here goes to the front. I'll show you that in a minute when we do our brake input. So this brake wire is going outside to our switch and up to the brake controller. And then the blue one comes back from the brake controller into the cable that goes out to the back, to the actual 7-pin connector. Okay, so that's got everything here taken care of. The only thing we're missing at this point is our brake signal. So I'll show you what we did here. Brought this cable out here, and I'm tucking it in this little spot here where I believe it'll be protected. This is where we're going to get our brake signal from, this pressure switch right here. So what we've done is we've taken an air line right here, and we've teed off of the output. So if you find an output on your foot valve that goes to your brakes, orange is typically for your front brakes, green is typically for your back brakes, okay? Mine is coming off of the tractor protection valve. I might as well show you that too, because we added trailer brakes to the back of this truck and air trailer brakes. So it didn't have it before, so I had to put in a tractor protection valve. So I'll show you where this is under here. So since we had a tractor protection valve, this is one of our actuator lines. This one actually we teed into, and that gives us our pressure for our switch. Now you could put that switch right here if you'd like. I just didn't want my switch down here in the ground, close to the ground with all the dirt and grime. I thought it'd be better suited to be up away from all this mess. You have to be careful where you do this though, because sometimes if you put it on a valve that only has pressure when there's a trailer hooked, you could risk not having brake lights when the trailer is not hooked up, if that makes sense. So when the trailer's not hooked up, there's a valve in here that slides. So you got to make sure that even without a trailer hooked up, you're going to have brake pressure on this line here. So I don't have any batteries in the truck, but I want to test this line to make sure I'm tapped in the right place, because we want to have that signal regardless if we have any of our brake valves pushed in or a trailer hooked up or anything. We want this to have a signal at any time that you apply the brakes, regardless of what trailer you do or don't have hooked up. So we're using a digital volt ohm meter on each one of these terminals. We're going to go inside and we're going to apply the brakes. Now again, I don't have a battery in it, so I've got shop air plumbed in to it. I got a little air leak here. I took this pressure valve out because we're doing some detail work and I'm going to be moving that valve. But let's see here. Should be open. We are. Press on the brakes. And we got continuity, let up, nothing. So this works properly. We push down, we have continuity, we let up, we're open. So we're set up correctly. So now we know where we've tapped in is correct, because again, if you tap in the wrong place, you may not have that brake signal due to the fact that there may be a valve that changes direction when you don't have a trailer hooked up. So you got to be careful of that. So you want to make sure you're testing what you're doing beforehand. So now that we know that's good, we can go up here and I can make my terminations for up here. So I've got my signal wire terminated now, and I've got everything loomed and zip tied. These are future use wires that I was talking about, and I like to put heat shrink on the ends of them, and then I fold the heat shrink over and put another layer on it just to keep as much moisture out as we can until we're ready to use these. Now, I will be probably in the next phase and be adding some more stuff to this that requires me to have switches inside and outside, but for all intents and purposes, I think we're just about ready to test. We have everything positioned, at least enough to test and show you, and we have our wire for our trailer brakes run all the way to the back. Now I have a big junction box here for a bunch of other stuff that's going on, but for the purpose of this video, we're just gonna say that our line comes back here to our 7-pin, so we're gonna get ready to test that just as soon as I terminate a few things in my junction box. I've finished up my wiring back here, so now we're gonna test it. So first we'll start with turn a key on, we'll do left turn, then we're gonna do marker lights. So after everything, you're gonna turn something off. So key on, left turn that off, then marker lights, then right turn. And then I'll tell you more from there. All right, this will be our ground, which is right here. And we're gonna go left turn, marker, right turn, no, right turn, marker, left turn, back up, trailer brake, charge line, stoplight. Okay, keys on. Okay, left turn. Oh. Okay, turn that off. Okay. Parking lights. Okay, turn that off. Right turn. Okay, turn that off. Put it in reverse. That's all the way closest to you and forward towards the dash. No. What? No. Okay, that's good. Take it out. Now squeeze the brake controller. Okay. And this will be our charge line. Now we gotta check our brake signal, which means I gotta put air into the tank because we don't have any air yet. How much pressure you got in that tank? The gauge show. Nothing crappy. It only takes like 5 pounds, so we should be able to push on that brake pedal and it should work. Go ahead. Push it. Okay, let up. Okay. Now we should. You getting anything on? Yeah. See how the brake controller lights up? Okay, so we got input to the brake controller. So now what I need to do is put my test lead on the brake wire to see if it works with that. Okay, so we gotta get back to our brake wire. Let up. Right here. Okay, hit it. What? Push the brake. Okay. There we go. Let up. Okay. Now we just need to test this at the 7-pin to make sure that it's working properly down here. I need 2 hands to get it set up, so get this done. Hit the brakes. Let up. Yeah, okay, so that's working. Now I need to check our charge line up in here, make sure it's working. Charge line works too, so we're good to go. Well, all I'm doing is just feeding the system with the shop air. I've got a leak right here we gotta fix. I might just replace the tanks because these things run out pretty quick, and I may have another replacement set that's nice. Let's see. Hit the brakes. So when the indicator light comes on, it tells us that we know we have input, but there's no trailer connected. If we had a load back here, it'll read a number. When I had that hooked up, did you see any number come on? Mm-mm. All right, I'm gonna go hook it up and we'll try it. Yeah, there you go. See how it's coming all the way up to 10? It's sensing we have a load on. That light is enough. So let up. Hit it again. So that has the gain all the way up. So if we turn this down, this 0 means how this tells you that you're in this ramp up setting. Go ahead, back off. That's how long it takes to come up. Now hit it again. See how slow it comes up to the voltage where it was before? See how it's coming up nice and slow? Let up. And if we move that closer to us, it's going to come up even faster. Go ahead. There you go. Okay, let up. Now we'll go all the way. Go ahead. Let up. Now we'll go back to real slow, and then we're going to back this down a bunch. Okay, go ahead. Okay, a little bit. Alright, so there's about 4. Let up. Hit it. See how it maxes out at 4. And then we can just turn this up or down to whatever we need. Okay, I think we're good to go. Everything is pretty much handled except for my circuit breaker and the batteries. And like I said, I'm in process of this truck, so I really don't have the ability to set that up yet. But this junction box isn't bad. But I think for this particular application, I would have been better off to buy my own Carlon box and cut my holes where I need them and make my own bus bar, because this got very, very tight. It was hard to keep it organized, and I knew I'd have a few extras. I wouldn't have enough terminals, and I only had 3, and it's just these splices. So everything else is on here because I had so many wires. Like a lot of these have 5 wires going on each circuit. So anyways, that's it. Alright, so that's the end of this for putting electric trailer brakes on an air brake truck. So I hope you guys enjoyed that. If you had any questions, I hope it covered it enough that maybe you might be able to do it yourself if you were looking. I tried to cover everything I could. The only thing we didn't do was the termination of the battery, and again, it's because this truck is in process and I don't have my battery box mounted yet. But we would put a 30 amp resettable, weatherproof, weather tight, whichever, circuit breaker right at the battery. So that's the only thing we didn't do. Next on this truck, we're going to be mounting the fifth wheel. From previous videos, you saw that we got a sliding fifth wheel taken apart. We inspected it, we cleaned it, we primed it, we painted it. Now that all the wiring's done, we're going to go ahead and get that on here. That'll be a big, nice step. And my parts came in. I ordered some parts from lights from PartsAm. I've got some really nice taillights we're going to be putting in, and I've also got some really, really cool turn signals coming that I can't wait. Our turn signals, really cool headlights that are coming in. They are pretty neat. They just came out. I don't know if they're actually released yet, but regardless, we're putting them in this truck. They're really cool. Some of the nicest, neatest, elaborate LED headlights I have seen yet. So if you follow us on Facebook, you've already seen these headlights because I've already posted them on there. They're so cool. But anyways, thanks for watching. We'll catch you on the next one. See you guys. That's to help anybody else in the future. I have a rough diagram over here that I've hand drawn, but it's pretty confusing if you're not the guy who did it. So I'll take some time and I'll do this up pretty nice and neat. At least it'll be able to decipher something.